Okay, here we are. Today what we're talking about is the logarithm rule. So they have rules, and they all come from exponents, okay? So one of the things I like to do is just show a couple of things before we even start. I know three things. X squared times x cubed equals x to the 5. So when I multiply bases, I add exponents. It's true about logarithms because logarithms are exponents, okay? And the same thing if I have a x to the 5th divided by x squared, it's x cubed, because when I divide bases, I subtract the exponents. The same are true of logarithms because they are exponents, okay? And if I have an exponent to an exponent, I multiply it, I get x to the 15th, okay? So the same thing with logarithms, okay? Because logarithms are exponents. So we know that logarithms are exponents. We start with this, some answer, some base to an exponent. We know logarithms equals the exponent, so logarithms are exponents. So we have these log rules, okay? So first of all, if we multiply two bases, we add their exponents. Well, the logs are the exponents, so I've got two bases multiplied. So we change the times to add, and we add the exponents. So log of n plus log of m. So when we multiply, we add logarithms. The same thing is true of division. If I have logarithms, if I divide bases, I'm going to subtract their exponents. That's an exponent minus an exponent, okay? So when I divide, I subtract the exponents. And then a basic rule, if we have log b of n, if the bases are exactly the same, we can cancel the bases, and we can have just n equals m. Okay, that makes sense. Same log, okay? The last rule, which we use the most, is the power rule. So if you have an exponent to an exponent, or if you have a log to an exponent, if you have a log to an exponent, you can float the exponent down. So you bring the exponent down, bring it out in front, and multiply, because you really do have a exponent to an exponent, so you multiply exponents, okay? Now, let's use that. So in example 1, I see the times. Two bases will be multiplied, so I add their exponents. So I rewrite it as log base 3 of a plus log base 3 of b to the 4th, okay? So if I multiply, I add the logarithms. And then another thing I'm going to do is this b to the 4th. So I'm going to use this rule here. I'm going to float the exponent down. So an expanded form of log base 3 of a plus 4 log base of b. Okay, example 2 does the same type of thing. If I see divide, I know divide is going to be a subtraction. So before I did anything, though, I do know the square root of these. That's the square root of that one and the square root of that one. Okay, so now divide means subtract. So I subtracted the two bases by subtraction because I've got the log base 5 minus log base 5. Then what I did is I made that into an exponent. This is 3/2, 1/2, because square root is the same thing as 1/2 power, right? Same thing as 1/2 power. And then finally I brought down the exponents, because if I have the power rule, I can bring down the exponents. Brought down 3/2, and brought down the 1/2, and multiplied exponent times exponent. Because remember, logarithms are exponents, okay? On example 3, we're going to do just the opposite. We're going to bring it together as a single log, so we're going to bring it together. This minus here, I'm going to bring it together as divide, but before I do it, I'm going to bring back in the exponent. So this was an exponent. I'm going to reverse this rule here. I'm going to bring back in the exponent, so the 3 comes up, makes it going to be a cubed, and bring this 1/2 up and bring it to b to the 1/2. And then I'm going to apply the rule. If it's subtract, I can bring the bases together as divide. So the subtract here is this division sign here, okay? And lastly, I may as well make that a square root. Okay, now finally, example 4, not finally, but example 4. So to express in terms of y's and x's, I got to get rid of all the ln's. So the first thing I did is, okay, I'm going to try and simplify this, make it tidier. So I brought the 1/3 in first, because that was, I'm reversing the power rule. Doing the opposite of that. So I brought the exponent back in. And then, because of this plus, I'm bringing it together as multiply, okay? I might want to rewrite that as a 4x, so I just did that. I rewrote all of that into that term. And then finally, if I have the log equals log, so I'm applying this rule here, where log of something equals log of something, then the n has to equal the m. So in this case, I applied that rule. I can cancel out the logs and have y equals 4 cube roots of x, okay? I have things in terms of x. Okay, now, turn the page. Now I'm going to solve equations, okay? Now this is important because x cannot be 0 or negative, because you can't do it. It's undefined. So to do this, the first thing I'm going to do is combine these. So I brought these together. See, plus, brought together as times. So this is an invisible times here. Okay, so I went log base 4 of x minus 4 times x. And then I have a log of 4 equals a log of 4, so I'm going to apply that rule right there where I cancel the logs. Okay, cancel the logs. And then I have x times x minus 4 equals 5. So I multiplied through, and I got a x squared minus 4x equals 5. Looks to me like I'm going to have to factor, so I need to make it equal to 0. So brought over the 5, subtracted the 5, brought the 5 here. I factored this to x minus 5, x minus plus 1, because those are the factors of negative 5 that make a negative 4. And then, of course, I'm solving my mini equations. I set them both equal to 0. I get x equals 5, x equals negative 1. Now, that looks great, except for we did say that x, the values have to be greater than 0, so we threw out the negative 1 because it's undefined. You can't have log of negative 1, okay? You can't. Example 6 is a little bit different. First thing I did is I combined them, make a single log. I see the plus, so bring out those times. You don't see a times sign, there's an invisible times there. So log base 2 of x times x minus 2 equals 3. I can't get rid of the logs, but I can change from log form to exponential form. So I'm going to go 2 to the third power equals x times x minus 2. So I'm just using this rule here, which is the rule we learned yesterday, okay? So we took the base to the exponent equals the answer. So I did with 2 to the third power equals what's inside. So then, what is 2 to the third power? Well, 2 times 2 times 2 is 8. X squared minus 2x. I subtracted the 8. I factored x minus 4, x plus 2. I did my mini equations. I got x equals 2, negative 2, and x equals 4. But I can't have the negative 2 because logs can't be negative. And so we just wind up with x equals 4. And that's all I have. So if you have any questions, come see me, and there is the homework.